Hello, welcome to the 44th talk in the NOAA Environmental Leadership Seminar Series, or NELS. The goal of these seminars is to share examples of NOAA's role and impact in environmental science by those who lead and make it happen. My name's Allison Burrell, and I'll serve as your MC today. We thank the NOAA Science Council for sponsoring these webinars and the NOAA NELS team that make these seminars possible. The members of the team are Katie Poser, Sandra Clark, Robert Levy, myself, and Dr. Hernan Garcia. All right, just a few seminar logistics before we get started. This is being recorded for later viewing. The access to closed captions, please click on the CC button. It's at the top of the Adobe Connect screen. In addition, we also have a live transcriber, Julie Clements. Thank you for your support, Julie. And for all the online attendees, you're muted, but you may post questions in the Adobe Connect Q&A box at any time, and you can find that at the bottom of your screen. At the end of the talk, we'll address as many questions as possible. So today, I'd like to welcome our guest, Jennifer Koss, Director of the Coral Reef Conservation Program, otherwise known as CRCP, at NOAA's National Ocean Service. Her seminar is entitled Coral Reef Conservation Program 2.0, the new era of coral reef conservation in the U.S. Just a little background on Jennifer. She has an academic background in oceanography, biology, and marine policy. And before stepping into her role as director of CRCP, she worked on conservation issues with other offices, including EPA's Chesapeake Bay Program Office, NOAA's Restoration Center, and the Program Coordination Office of the NOAA Administrator. Jennifer also serves on the advisory board for the Global Fund for Coral Reefs. She is the vice chair of the Coral R&D Accelerator Program and just spent 3 years as the co-chair of the International Coral Reef Initiative. But without further ado, I'll now turn it over to Jennifer. Thank you for taking the time to talk with us today. The floor is yours.
Thank you very much, Allison, and thank you everybody for tuning in. I'm going to talk to you a little bit about NOAA's Coral Reef Conservation Program and some of the things that are happening currently with coral reefs and what makes us relevant and the things that we are working on currently now that we have been reauthorized. So with that, I'm going to get right into the talk. And I think Allison did a nice job of recapping about me, so I will move on from there and talk to you a little bit about the importance of coral reefs. We're still understanding exactly how much coral is out there, the different complex of species that make up stony corals, and the number of species that live on or in reef areas. So we've got rough estimates of roughly 2 million species living in coral reef areas, which is beginning to beg the question, are coral reefs the rainforest of the seas, or are rainforests the coral reefs of the land? And older estimate, probably a good 5 to 10 years old, is that there are greater than 500 million people who rely on coral reefs for some part of their life, whether it's their livelihood or the island that they live on, or protein security in the form of fish. And there's obviously an enormous number of different cultures and livelihoods that are dependent on coral reefs. More recent studies have done a really good job in quantifying the infrastructure that exists behind coral reefs and what those coral reefs do to protect the infrastructure, whether that's a school, a hospital, a business, a road, critical infrastructure in coastal areas. The USGS has done it for all U.S. coral reef areas, and so we have a far better understanding of the benefits that corals provide in terms of reducing wave energy. So a healthy coral reef can dissipate as much as 97% of a wave's energy. And an untapped area of economic gain in the United States and worldwide is that in biopharmaceuticals. So there's already a number of different medications and treatments for things like asthma and inflammation and cancer that have been derived either from the coral itself or a critter that lives adjacent to or in a coral reef area. So with that, I'm going to have the folks queue up a cute little quick draw thing that we had done that'll do a little bit more information on the economic benefits of corals.
Every year, coral reefs pump more than $3.4 billion into the U.S. economy, from the seafood we eat to the medicines we take. How does that happen? Although coral reefs cover only a tiny fraction of the planet, they support a quarter of all marine species. Many of the fish we eat spend some part of their lives here. Harvesting these fish supports thousands of jobs. Another benefit? The ability of coral reefs to reduce storm and wave energy. This protects the coastline, saving lives, livelihoods, and valuable coastal property. Researchers are also tapping coral reefs for new medicines to treat everything from cancer to arthritis. And let's not forget the role tourism and recreation play in the coral reef economy, attracting visitors who gladly pay for the opportunity to dive and snorkel among the corals. Reefs and reef fish even have a hand in creating the white sandy beaches we love. Our coral reefs are threatened, and so are the goods and services they produce. Climate change, pollution from the land, and harmful fishing practices top the list of threats. Fortunately, it is not too late. We can protect these remarkable ecosystems. Visit us online to learn about NOAA's Coral Reef Conservation activities.
And for those of you interested in that, we had the talents of Michael Pye out in our Hawaii office that did that graphic for us. So it's a lot of fun, and it's nice to be able to share that with everybody. In the video, we talked a little bit about the impacts to coral reefs. I think universally it's well understood that the twin aspects of warming ocean waters and more acidified waters that are coming about as a result of climate change, those impacts are globally the biggest threat to coral reefs. Warming waters tend to cause corals, when they're too warm for too long, the corals will eject their photosynthetic algae that lives in its tissues. They have a symbiotic relationship with that algae, and that's where they primarily get their nutrient and energy from. Corals can also feed what's called heterotrophically. They can essentially grab planktonic life forms out of the water and feed themselves that way. They have these little stinging cells called nematocysts, like jellyfish and anemones do. So they have two different ways they can feed themselves, which will become important later on in the talk. But bleaching, in essence, robs the coral from its ability to feed itself. And if the coral is bleached for too long, it will ultimately die. It can re-recruit that symbiotic algae if the bleaching event isn't too long and too intense. And I did want to point out that the graphic in the lower left corner there is not a picture of bleaching. That's actually a picture of disease progressing across a coral head. But the upper photos, those are definitely bleached. So when you see that white skeleton underneath the tissue exposed like that, that's why we call it bleached, because the coral literally loses its color. The algae is what has color for corals. And we are currently in the midst of the 4th global bleaching event, which I will also talk about a little bit later in the program. Some other threats that are ubiquitous for corals are overall water quality. So anything that comes off the land, we call it land-based sources of pollution. You can kind of lump marine debris into that in terms of affecting water quality, affecting the corals themselves and the other associated organisms that live in those reef areas. Fishing impacts happen in two different ways. It can be both the type of gear that you use, as well as the amount of fish you're taking off of the reef. So things like cyanide fishing and dynamite fishing are incredibly harmful. That doesn't happen in the United States. That's more had been happening in Southeast Asia. It's been largely eradicated. People understand that it's kind of a one-time fishing opportunity if that's the way you're going to fish. And then in terms of overall removal of too much fish in different taxa, which can really affect the way that coral reefs function. So reefs are in balance, the corals are with algae, and if things get out of whack, sometimes the algae can overgrow the reef and rob the reef, coral reefs from getting that sunlight that they need to thrive, and having other organisms like fish and invertebrates that graze down that algae is super important. So when you essentially alter the balance of grazers to non-grazers on a reef, you can ultimately end up impacting the overall health of the reef. So it's important to make sure fishing practices are as sustainable as possible. And then there's just general fish damage that can happen through storms, and a lot of damage, unfortunately, is also anthropogenic in nature. So we'll get ships and sailboats and other things end up colliding with reefs if they don't know where those reefs are via their nautical charts. And then also we have things like oil spills and chemical spills, and there was actually a spill from a molasses plant in Hawaii that ended up impacting a reef. So a lot of different things can happen that we need to be consistently addressing either after the fact when the damage has happened, or to try to prevent it from ever happening through different regulations and best practices, and setting up coral reef managers to know what to be on the lookout for. So I mentioned a little bit that we are in the midst of the 4th global bleaching event. The last one was from 2014 to 2017. I think this graphic is a tiny bit out of date. I think we're up to closer to 80% of reefs bleaching in this event. And what that means is that waters around the world are warm enough for long enough periods of time that the conditions are ripe for corals to bleach. It doesn't necessarily mean they will bleach, but it's a very good indicator and a good trigger for managers to get out and look and see if their reef areas are bleaching. There are some corals that seem to be a little bit bulletproof, and it may be that they're just in a great location. They may be right next to a cold water upwelling that will keep them from bleaching, but this is definitely the most pervasive bleaching event we've seen, and it's not yet over. So that's something that we watch, and NOAA's ability to do that is our Coral Reef Watch program, which is operated out of NESDIS. And it's a product that reef managers around the world greatly rely on, and we're very proud of it, and it keeps improving as time goes on, and we get better sensors and better ways to monitor the corals, either through networks of people who are doing it, and then we're even looking at some remote technologies to see if we can monitor bleaching remotely. But so I've just given you a whole lot of reasons to think, oh God, things are awful for corals, and they are, but it's really not too late. As I mentioned, corals can recruit that algae through a bleaching event, and here we have a nice time series of a coral that did bleach and then did ultimately re-recruit its algae and looks pretty healthy there. That is not to say that the coral hasn't taken a hit biologically. I think it takes a lot of energy to re-recruit that, and the next year of spawning may be impacted, but it's good to know that corals do have that resilience to come back from a bleaching event. And we'll talk about some other things that we're doing to improve the innate resilience of corals through the Coral Reef Conservation Program. This is just a little bit about the program itself. We were authorized originally in 2000, and then were reauthorized in 2022 through the National Defense Appropriations Act. And we've had various strategic plans over time. We're always constantly tweaking the way that we approach management and science to best fit the current conditions of corals. So this is a little bit of a timeline of different aspects of the coral program. So we are in our 25th year, so we're celebrating the 25th anniversary of the Coral Reef Conservation Act and the 25th anniversary of the Coral Reef Conservation Program. The program itself is multidisciplinary, and we rely on a resilience-based management approach. So early on in the tenure of NOAA's Coral Reef Conservation Program, there were several different appropriations that came into different parts of NOAA. And in the 2003-2004 timeframe, the Commerce Committee said, hey, NOAA, why don't you create a singular Coral Reef Conservation Program with one PPA? And at that point, it was determined that the appropriation should come to the National Ocean Service, but all of the different activities that had been going on under different appropriations would be incorporated under one umbrella. So what the Coral Reef Conservation Program does for us is it allows us to tap into the existing skill sets that are across NOAA, bring those to bear for coral reef conservation without duplicating the effort in another office. So I just mentioned all those different threats, and I'll show you a bit of a schematic of how big the coral matrix is in the next slide or so. But what it really does is it allows us to take a threat-based assessment and mitigation strategy by tapping into different parts of NOAA. We are able to tap into different parts of NOAA to improve our ability to restore coral reefs, to monitor and map coral reefs. And inherent to the program is definitely to work in constant partnership with our state and territorial partners, as well as other federal agencies, because it truly takes a village. And there are some things that NOAA is poised to do very well as a federal agency, but then it's really at that local level that the actual management action needs to take place, because the great majority of coral reefs are actually in, and I'm speaking only of shallow water coral reefs, are in state and territorial waters. So if you've been around in NOAA long enough, you probably know there's also a mesophotic coral reef program that's in NCOS in the Ocean Service, and that's that kind of next layer down. Sometimes they call them twilight corals. They're the ones that are a little less light dependent than the shallow water ones, but largely the same species complex. And then there are truly deep corals that do not have any reliance on light. They're very slow growing, and they're in deep, dark conditions, and are obviously great habitat for deep water fisheries. And so that program exists in the National Fisheries Service and the Office of Habitat Conservation. So a lot of attention on corals, but different ecosystem of corals, because they all kind of take slightly different management actions necessary to make sure they're persisting. This is a brief snapshot of our appropriation over time. What's interesting is we were authorized originally in 2000, and that appropriation was at $16 million, but we never got $16 million. We've always had more than our appropriation, which is wonderful. I think Congress recognizes the job is slightly bigger than how they originally described it in the Coral Reef Conservation Act. So we've had a nice steady increase over the years. We had a little bit of a high mark there in the 2008, 9, 10 level. That was when earmarks went away, and so additional funding for Coral Reef Institutes was placed in our budget. So that diminution isn't really a decline in the program. It was more a Congress needing to get some additional funds to the Coral Reef Institutes. But overall, a nice trend upward. And we're currently authorized at $45 million. And I hope that Congress keeps increasing the appropriation so that we can do everything that's in the new Coral Reef Conservation Act. I mentioned the word matrix, so this is the formal structure of the matrix here. It is equal parts Ocean Service, OAR, the Fishery Service, and our satellite service. And there's a brief snapshot of some of the folks that work in the coral program. So the last time we created a strategic plan, we really mapped out what does the matrix look like. So the pillars of work on the left, and then the strategies we mapped out against the different financial management centers that make up NOAA's Coral Reef Conservation Program and the matrix, and put little check marks to show internal folks as well as external partners in Congress what different parts of NOAA do we touch and rely on in order to implement our strategic plan and uphold the Coral Reef Conservation Act. So that expertise is really all over the agency in different ways, some totally obvious and some not as obvious. But I, interestingly, have never had a job in NOAA where I didn't operate in some form of a matrix. So I've always had a nice understanding of what NOAA does as an entire agency, and really rely on the marvelous science and management expertise that exists across the agency. And it's been a joy to be the leader of this program and be able to interact with so many super passionate people that make up the coral matrix, all pulling in the same direction and doing a wonderful job, which is not to say that it's always easy to manage all those expectations, but I think everybody's doing it for the right reasons. A little bit of a geographic orientation in case you haven't really thought about where are are U.S. shallow water coral reef sources. So they are as far east as the Virgin Islands, way out there in the Atlantic time zone, and then all the way out to the Marianas, which I think is the Chamorro time zone. So that's 9 different time zones, big program. It's hard to have a staff meeting when you have that many time zones to work with. The darker blue areas are where there are high concentrations of people. So a lot of where our management actions take place. The lighter, kind of more turquoisey areas are largely uninhabited. And that's really only monitoring and science that happens to make sure that we're understanding what the condition of corals that are relatively left alone from humans, what their condition is, and they're a nice test bed for where it's primarily just the impacts of climate change that are affecting coral reefs. So another big hurdle for us to try to figure out how to monitor those corals in an efficient way, frequently enough to understand trends. Largely our National Coral Reef Monitoring Program is conducted on NOAA's big white ships in the Pacific, and then we do smaller boats and even some shore-based activities in the Florida Peninsula area as well as the Caribbean. It's a little easier to do that on contracted vessel. We don't need the big white NOAA vessels to do that. So getting Pacific coral monitoring done has become increasingly harder as the fleets become a little bit more strapped, and different ships have been mothballed for different reasons, but we try to make it work. And then we have a little bit of an international program, and more for biological connectivity reasons, especially in the Caribbean. Corals are very interconnected with each other. Some reefs are downstream of others and receive the coral larvae that get produced through sexual reproduction. And then it's really incumbent on working with those international partners because we do have the ability to impact each other's reefs. And then so in Micronesia, we have a program. We're not doing as much in the South Pacific. We used to have more of an initiative with Samoa proper and American Samoa. That's not as robust as it used to be. And then we've been doing some work in the Coral Triangle as well. But that's really decreased over time as resources have become a little more dear. So the the Coral Reef Conservation Program is within NOAA, but then outside of NOAA is the U.S. Coral Reef Task Force, which is co-chaired by the Department of Interior and NOAA. And that had been originally established through a presidential executive order in 1998, and then was actually included in our reauthorization bill in 2022. So it's codified and is now in statute. And what that allows us to do is work super closely with our state and territorial partners, as well as the other federal agencies that have different mandates and resources that are of direct consequence to coral reefs. It's a little bit of an eye chart here, but it's 13 federal agencies, our 7 state and territorial partners, and 4 fishery management councils, and then there are 3 freely associated states which also have more or less sort of observer status. So it's a large group of people, and everybody bringing different mandates and resources together and operating under a framework for action, which is largely consistent with our strategic plan. So it's been an amazing snapshot of U.S. government to understand what all these agencies do and how their assets and resources can help directly with our partners to manage those critical coral reef areas. The way it's constructed is there's the principal member of the task force that when we meet in person sit at the big head table, and those are usually folks that are fairly highly up in those federal agencies, generally political appointees. And then the bulk of the work gets done at the steering committee level. So that's people like me that are career feds, and some contractors that work on keeping the activities of the the U.S. Coral Reef Task Force going. And then that work is subdivided down into topical working group areas. So currently we have a watershed working group that really works on watershed management and keeping sediment and nutrients from coming off the land. A group that's looking at climate change impacts. How can we better harness the innate resilience of coral reefs? A coral reef restoration working group, a group that focuses on enforcement, fisheries, communications, and then coral disease. So it also broadly mirrors the activities that happen within NOAA's Coral Reef Conservation Program. And that's a pretty dynamic group of folks to work with. I've mentioned that we got reauthorized. The new things that came in the Coral Reef Conservation Act that weren't in the previous one is it called for us to write a new National Coral Reef Resilience Strategy. And instead of that being a single agency strategy, i.e. a NOAA strategy, it is meant to be the strategy for the entire task force. And how that would get implemented is through coral reef action plans. And so those are meant to be developed at the local level and be a time-bound 5-year plan of action for each coral reef manager to follow that's consistent with the resilience strategy. So that's kind of where the rubber meets the road in terms of actual direct interventions and management. It also calls for the creation of coral reef stewardship partnerships, which are meant to be academic, NGOs, federal, local government, all working together in the same areas, in the same reef management units. And so we've undergone an exercise where we worked with our state and territorial and federal managers and defined those reef management units for all coral reef areas in the United States. And then key to everything is funding. So Congress also has asked us to create a new block grant program. Previously, we'd been using cooperative agreements and just traditional competitive grants. This is the first time we've ever undertaken block grants. That had us doing quite a bit of research. There aren't any analogous block grant programs in the U.S. government that we've found that are specifically for natural resource management. Block grants exist for other reasons, and it's not really analogous to what we're trying to do. So we've done our best to figure that out, and I think we've got a pretty strong model going forward. And we're working with our state and territorial partners now to get the first round of applications in from them, which will really truly kick off our block grant program. So that's been exciting and a little bit of an audacious undertaking since we've never done anything like that. And then the Act also had us go through an exercise to create reef research centers and reef research coordination institutes, which I'll talk about in the next slide. I talked a little bit about the resilience strategy being more comprehensive than just NOAA. So this is really truly encapsulating the vision of the authors of the CRCA that they wanted every coral reef area in the United States to have a management plan and a singular strategy that is an umbrella for all of those management plans. It's sort of leveling the playing field. So where we have federally managed marine protected areas like a sanctuary, a wildlife refuge, a national park that has a coral reef component to it, they all have management plans, but that doesn't necessarily mean that there are management plans for all of our state and territorial coral reefs. There are marine protected areas in each of those areas, but Congress was like, you know what, everybody needs a management plan, and this is how we're going to do it. So the resilience strategy is the umbrella document, and then through the creation of coral reef action plans and with the help and assistance from coral reef research centers and reef research coordinating institutes and these stewardship partnerships I talked about, that's how Congress envisions the actual day-to-day direct management of coral reefs to happen. And then federal agencies there to help create product tools, develop best management practice, do some of the larger scale research that's really critical to inform management. This is a schematic of how we envision all of this to work. So you can read the vision statement there: thriving, diverse, resilient coral reefs that sustain valuable ecosystem services for current and future generations. And so how do we do that? I mentioned before that we are adopting and have adopted, we did it in the last plan, a resilience-based management approach. And what that means is anytime we come up with a management action or create a strategy or create a plan, we're looking for not only the current conditions of what corals are experiencing, but what are things going to look like in the future? How much warmer are oceans going to get? How much more acidified? To the extent that we can, how can we plan for restoration that's resilient to storm threats and other things that may come along. Again, relying on that innate resilience that exists within corals, and how can you harness it and make sure that corals are not only vibrant in current conditions, but will persist through time. And then, so that, keeping that in mind as your overall arching theory of what you want to do, the new resilience strategy talks a lot about the necessary technical and administrative capacity that needs to exist so that managers can carry out these important actions. It focuses on threat reduction and the technical assistance that federal agencies can bring to achieve that threat reduction. Then we propose to take an adaptive management approach where we're learning, constantly learning. If something fails, we'll take lessons learned from it and do it better the next time around. And then we're constantly testing what our management strategies and mitigation strategies look like and improving them over time. And then you can see there that there's several objectives that are in the new strategy that are similar to the old one and adopt some new things as well. Unfortunately, we've had a new disease pop up, 2014 is when it was first described, but it's the stony coral tissue loss disease, which has ravaged the Caribbean corals, has not gotten into the Pacific, so we're doing a lot there. But our previous plans were not as heavily focused on disease as this one is. So it's a lot of disease treatment where the stony coral tissue loss disease exists now, and then prevention of it getting into the Pacific. A lot of focus on that. And then otherwise, it's same old thing in terms of sustainable fisheries, reducing land-based sources of pollution, and then understanding how people value those coral reefs, and how with some additional education and support, we can get to some critical behavior changes in coral reefs areas for the folks that directly engage with them on a daily basis. So that's a quick overview of how we hope all of this maps out. And then we're in the final stages of editing the resilience strategy, and we'll shortly go through a line office clearance process and then package everything together and give it to NOAA downtown for their clearance, and then eventually give it back to Congress so that they can see the results of what they put in motion back in 2022. So it's a lot of the same things that I've already talked about from past things, and we just keep adding. The unfortunate part of coral reefs is we never get to walk away from something. It's always and, never or don't do that anymore. I think we've probably scaled back a good bit of our mapping efforts when we were first trying to figure out where those corals were, but now we're going back and mapping in much higher resolution in order to inform restoration strategies. So you can see there, it's management capacity, land-based sources of pollution, disturbance prevention, preparedness and response. That's where a lot of our disease work fits in. Understanding how to make corals more resilient to warmer ocean waters and more acidified waters, constantly working with our fishing community to make sure those practices are as sustainable as possible, and then really growing the field of coral restoration. That has just exploded in the last 10 to 15 years. Before, we were only really responding to shipwrecks, and now it's replacement of corals that have lost, where we've lost structure, really trying to get back those critical ecosystem functions that corals and services that corals provide. I talked a little bit about the Coral Reef Action Plans. They are 5 years in nature and should mirror the National Resilience Strategy. So those will be written over the next year or so, and we fund those through the block grants and through a couple of other grant programs. So those will be, we're trying to make sure they're all consistent with each other for easy quantification of the efforts that are being taken at the local level, and to be able to do that adaptive management approach to coral reef conservation. This is just a quick graphic here of the different funding opportunities that we've got. One of the new things in the CRCA was to create an emergency assistance program that is currently housed in the National Fish and Wildlife Foundation. So that allows us to rapidly respond to an emergency. Corals don't have a lot of time if they're disturbed, and waiting for a traditional grant cycle to go through is too long of a time to immediately respond. So we put a new program together with NIFWIF to allow managers to respond in a timely fashion and reverse a lot of the damage that happens in an emergency. And then when you move from the emergency assistance phase of coral intervention, then we go into the disaster fund, which is also at NIFWIF, which is longer term recovery as a result of an emergency or disaster. And then some competitive grant programs there. I want to talk a little bit about the research centers. The CRCA said, please go ahead and designate coral reef research centers throughout all 7 coral reef jurisdictions. And we went through that process, and we now have 32 institutions, 23 in the Atlantic, 9 in the Pacific. And that designation basically says they're eligible for funding through the different grant programs that we have. And this is an additional source of expertise and science that can be brought to bear above and beyond what NOAA and other federal agencies can provide. And then from that group of 32 centers, we are currently going through a process to designate 2 Reef Research Coordination Institutes. So you can kind of think of those as NOAA cooperative institutes light. We did a lot of work to create the funding announcement and to create the structure of these institutes to be similar to. It's not 100% a new NOAA CI. It's slightly I think less robust, and very targeted for both coral science and management and capacity activities. So the merit review of the applications that came in is happening now. And in the not too distant future, we'll declare who those 2 institutes are. There'll be one in the Atlantic, one in the Pacific. And under full appropriations, there's $4.5 million to split between the 2 of them for federally directed science and management activities. Those institutes will also be capable of taking on other types of funding to be able to target research or a management activity or a capacity building activity at the local level too. So if anybody has spare funds that they want to bring to bear in a coral reef area, we have a viable way for you to obligate those funds. And then in terms of how are we staying relevant, corals manage to stay relevant all on their own. Through the 4th Global Bleaching Event, which we announced last spring, we had a huge reaction in the media. Derek Manzello, who heads up Coral Reef Watch, did hundreds of print and other different types of media interviews. I did a few, and as did other folks. So that certainly garnered a lot of attention when you declare a global bleaching event. Also, the recent studies that the USGS did that quantified those protection values of corals stemmed a good bit of work through the U.S. Coral Reef Task Force. And what we were able to do a couple of task force ago was to pass a resolution declaring corals as national natural infrastructure, and really recognizing that a vibrant coral reef is essentially a self-generating, not only economic generator, but protection generator for the coastal communities that exist near coral reefs. Much like oyster reefs, barrier islands, wetlands have been recognized. We did that through the task force and have seen some interesting reactions to that. The DARPA, which is the R&D end of the Department of Defense, is hosting essentially a competition to create hybrid reef structures that are meant to protect U.S. military installations in coral reef areas. They have a 2-pronged approach to that. There's also one that's happening for oyster reefs. So interesting to see a large amount of money come out of DOD to protect a lot of those Pacific assets and some Caribbean assets as well by harnessing that protection value that corals have. And there's also been a huge consensus in the United States as well as globally about the importance of corals, and a lot more funding coming from our Australian friends, and then interestingly enough through the Kingdom of Saudi Arabia when they were the chairs of the G20 The only environmental initiative that went forward was the creation of the Coral R&D Accelerator Platform. In over 10 years, the Saudis will put $100 million out in grants, really looking at coral resilience. How do we increase that resilience? How do we tap into it? How do we then make it replicable and use those resilient coral species for future restoration efforts? So they are attempting to develop their coastline of the Red Sea, and they know that the future of tourism is largely predicated on the health of their coral reefs. So that's been an interesting process to watch happen, and I'm happy to say that of the 2 rounds of grant funding that have gone out, it's been U.S. researchers, many of whom exist in NOAA, or in our partner academic institutions. The U.S. has been the largest recipient of those funds, and then the Australians really started paying attention to reef restoration when the northern 2/3 of the Great Barrier Reef bleached in the 3rd global bleaching event. So we see a lot more resources and expertise coming from the Australians. So that need to share information, kind of check your ego at the door, share data, and learn from each other has been at an all-time kind of fever pitch the last few years, and a lot of consensus about what needs to be done globally for corals. And then in terms of how do we stay relevant into the future, we're really learning how to communicate about corals in a different way. We're talking about return on investment. For a relatively small amount of money that's put forward, the economic benefit that the world and the United States in particular receive from corals is kind of astonishing. Corals occupy such a teeny part of the seafloor bottom, yet they convey so much benefit to humans in the ocean itself, that being able to talk about that in economic terms and in human value terms is becoming part of our dialogue. And then also really thinking about corals as another ecosystem that needs to be maintained. We're not going to be able to go out, restore a reef, call it done, and walk away from it. We reforest all the time. We replant vegetation after forest fires or other large storm events. We replenish beaches all the time to the tune of billions of dollars in beach replenishment. So thinking about corals in that same way is a way that we need to change that dialogue. And someone pointed out to me that we've been talking about restoring the Everglades for years, and that's in the billions of dollars of estimation to replumb the Everglades and get that hydrology right. And so we're really thinking more about corals as a critical infrastructure that need to be maintained, like other ecosystems that are considered infrastructure ecosystems. So that's the sort of the game changer for us, is how do we speak in those terms and get further support across the board, whether it's financial or behavioral change at the local level, so that people really know what kind of assets exist right off their coasts, and what amazing things that could be garnered from coral reefs in the future. So what do I hope you take away from this talk? It's not all doom and gloom. They are severely threatened. This is not the time to walk away. We have every degree of hope and the rapidly evolving science and technologies that we can take interventions now. Restoration and recovery is possible, but the time is to act now. When people say, when's the best time to plant a tree? Well, they say 10 years, 100 years ago. Same thing with corals. But we can't go back in time just yet. So the time is to do it now. And inaction is, in fact, an action and not the right one to take. Things will only get more difficult in the future the longer we don't take more aggressive and more holistic conservation actions. So we will continue to try to reduce those local stressors and implement actions to meaningfully address those climate change impacts, harness the innate resilience of corals, and keep plowing ahead. That is it, and I think we've got a good chunk of time for questions.
Thank you, Jennifer. Okay, I just want to remind everybody that you can still put questions in the Q&A box. We've got a bunch already. I'll jump in with like a sort of a technical question. As a result of disease or bleaching, I'm unsure if those are kind of the same thing, like does disease cause bleaching, or do you ever have them separate? And do that, does the algae leave on its own, or is it expelled by the corals in these instances?
During a heat wave, the corals then do expel their symbiotic algae. The disease is actually an infection, could be of, and we don't actually know a lot about coral disease. We haven't had a lot of resources to really quantify and even figure out what causes disease. Most of our disease work is descriptive: yellow band, black band, white band. Very descriptive, not terribly informative of what's actually causing it. So it could be a virus, a phage, a bacteria that affects a coral. So with stony coral tissue loss disease, that is a rapid tissue loss instance where when you see it go white, it's lost its tissue, whereas a bleached coral still has viable tissue, but you're seeing that exoskeleton underneath. So looks similar when you see it, but when you really look, you see that it's a different thing altogether.
And jumping over to conservation, we've talked about this a little bit off camera, but I'll ask you again. Like, I've heard that there's this Goldilocks window after bleaching where it can be reversed. So is conservation helping with this reversal, or is it just a waiting game if it'll happen or not?
Corals can recover from a bleaching event if it's not too severe, not too long. And there have been some experiments where people have fed corals while water temperatures are coming back down. It's obviously very costly and labor intensive, but it has worked in aquaria setting, and I think a little bit in the wild. So you literally go in and hand feed corals and allow them to feed heterotrophically, not relying on their symbionts. And if you can get them through that period where they can re-recruit that algae, then you can, but again, very, very cost intensive and probably not a great solution for coral bleaching.
So then in major events like hurricanes, how do you restore corals if they're broken? Is that something like how is that?
Yeah, same way you restore if a ship runs into it is you get out, you consolidate the corals that have been broken or toppled over, triage those corals. If you can put them back upright to where they were to begin with, cement them in, wire them, nails, anything to get them back into that matrix, then you need to stabilize the rubble. That happens both with storm events as well as ship groundings and anchor events, things like that. And then those smaller coral fragments, we call them fragments of hope, can be cached for future restoration activities. So the biggest thing is to get the big reef building species that may be face down in the sand back up and able to go through their normal life cycle activities, and then to take the smaller fragments and use them for future restoration activities. And interestingly enough, the real weedy species, the acroporids, small storm events are actually a reproductive strategy of them. The little fragments pop off of the elkhorn and staghorn and then go to another part of the reef and get lodged, and then a new coral will grow from that. So obviously huge events are not a great idea. You don't want to leave corals out on the reef that are unattached because they start to become bowling balls themselves for future events. But it's a very similar strategy to a anthropogenic event in terms of what they do. And there's a whole body of science and best practices documents on coral restoration. And that's really to respond to an event. The field of coral restoration has grown from responding to event now to trying to replace lost structure to regain ecosystem function. So that's what we're seeing a lot of happening in South Florida and the Caribbean, is to get those corals back.
So I recently read in the news about the big ship that was retired off of near Philadelphia, and it's being transported down to Florida, and that'll become an artificial reef. So can you take those tiny pieces and cultivate them somewhere and then plant them down there to help start a new reef? Is that how that works?
That's a really good question. And I personally feel like the field of coral restoration is now going more towards those hybrid systems. So you can either call it a hybrid reef or a gray-green reef, where you're using some alternate structure to get corals elevated off of the bottom of the ocean and recreate more of a reef-like structure, because trying to regrow a coral reef from teeny tiny little fragments up to something that's thousands of years old would take thousands of years. But if you use some sort of alternate structure, be it concrete, maybe a ship, you could simulate a natural reef structure in a much shorter period of time. So that's what the DARPA effort largely looks like, is using different forms of concrete substrates and then planting corals on it. So you get not only the wave breaking function of a coral reef, but then you get all the biological functions. So a truly artificial reef does not approximate a natural coral reef, just because of the biology is not the same. You don't get the same habitat value, you don't get the same biochemical functions going on, but some sort of hybridized thing is really the future of where coral restoration is likely to go.
A hybrid help with the reducing the wave energy for protecting coastlines?
Yeah. When you think about a classic coral reef, you've got sort of that fore reef that gets a lot of wave energy, and then you've got the reef crest, and then behind it the flat, where it's far more gentle, and the composition of species and the way the species even grow themselves is different based on those wave energy characteristics. So we're trying to get back some of that fore reef function in areas that have just gone flat.
So one person asked that they've had a debate with their diving buddies: is sunscreen safe around corals, and what is safe or does the least harm if they're diving?
So there's been a good deal of research on that. There was even a National Academy study on it, and the sunscreens that have chemical UV filters in them have been found to be deleterious to corals and other marine species, especially where the corals or the other species experience them in high concentration. So like if 3,000 people get off of a cruise ship, or you've got an entrained area like Hanauma Bay where the residence time of water is longer than an open ocean flushing system, and the corals get exposed to a fairly high concentration of those chemicals, they've shown those to be harmful for corals. What the industry is going now more towards is the mineral based, so non-nano, zinc, and I'm forgetting the other one, but mineral-based sunscreens, which are a physical block rather than a chemical block. But there's still a good deal of research that needs to be done on that, on the ingestion of those that National Academy's study said more research is needed. But you see a lot more mineral-based sunscreens available now than before.
When evaluating the health of a coral reef, I've got a couple of questions related to that. Are there any specific resources, whether it be site-specific or coral-specific resources to identify, degrees of bleaching, or just in general the health of corals? How do you evaluate that?
So our National Coral Reef Monitoring Program, we monitor 4 different large categories of indicators for overall understanding of condition, and then changes, so trends. So we're looking at the benthic habitat, what types of species are there, how big are they, are we getting new recruits, what's the overall condition of those corals in terms of, are they diseased, are they bleached, are they dead, or do they look healthy? Then we're looking at the fish composition in terms of overall size, different types of species. Then we do a lot of carbonate chemistry work to understand the conditions of the water column itself. And then on top of that, we have a socioeconomic survey that happens so that we understand that human dimension. How do people value coral reefs? How do they interact with them? What types of management activities do they support in order to conserve their corals? So we're looking at a suite of indicators over those 4 broad areas that help us to understand what's going on in our coral reefs, and help us to say they're declining or increasing in quantity and quality.
There's all those different things. Is there just like one quantifiable metric to evaluate U.S. coral health? Like, I don't know, they put together a mathematical equation of everything to give it a grade or something? Nothing like that.
But we really actually try to stay away from grading because that has a management implication to it. So we're really talking about more trends. Is this increasing or decreasing? Are we seeing more larval propagation? Are we seeing an overall decrease in a coral's ability to secrete its skeleton? So no, there isn't a singular indicator. I wish.
Okay, let's see. Somebody wants to know, are there volunteer opportunities to work on reef assessments?
True reef assessments, probably not. In terms of, because you have to have a lot of technical expertise to participate in our Coral Reef Monitoring Program, but assessments in terms of getting out in the water and saying, hey, I think you've got a disease situation, and then being able to alert someone. We've definitely relied on citizen science for bleaching reports, for telling us not only where, but the extent of bleaching. So there are different activities where we rely on citizen science as well as citizen participation. I think there's a lot more now kind of ecotourism things opening up, especially in Florida, to participate in restoration activities. Yeah, so there's ample opportunity for people to get involved in coral reef conservation as well as kind of science light.
I think, sorry, I'm jumping around in topics, but there was a little confusion. I think you had talked about in the very beginning of your presentation some pharmaceutical research, and how do corals help with pharmaceutical research? Like, they're not actually being used in the products.
Oh, but they are.
Oh, but they are. Okay, so explain how are you protecting them while also using them, and what is that balance?
Really good question. So if you think about a coral reef, they truly occupy a teeny tiny portion of the seafloor, and they're all kind of crammed in together. And so you can think of it as sort of constant biological warfare that's going on between different species, where you get too close to me and I'm going to make sure that you can't encroach. And so by looking at how do these corals eke out their own little space on the reef and the other organisms that are involved in really understanding those biochemical processes, it informs potential new medical advances. And generally, it's not an over harvesting of that organism as you figure out what the chemical property is, and then you make a synthetic version of it. So there are some ideas out there. One eventually called bioprospecting, that if you are a pharmaceutical company and you derive something from a coral reef species, perhaps a portion of your proceeds could go back to conserving that area. So yeah, there's been numerous things that have been derived from either corals themselves or the species that are dependent on corals that are treating, I think, definitely inflammation, asthma, cancer, and potentially, I think I saw something recently about Alzheimer's.
Well, some exciting research coming down, and I can't believe we're almost out of time, so I'm going to ask a final question. Is also talking about like measuring measurements. So how do you measure the impact from coral restoration projects? Because it sounds like it's touching upon so many things. I mean, you're restoring them, but it's sustaining them for research, for protecting coastlines, for protecting fish populations, which has that trickle down effect into our economy and what we put on our kitchen table. So how do you measure that? Is that an economics question, or?
It's both a biophysical question and an economics question. So like you can directly monitor the success of your coral. Like, are those corals growing? Are they attracting more fish? Are they attracting other typical organisms that you're likely to see, and quantifying things in those ways? So it's sort of like the more it starts to look like the coral reefs we understood existed in the past, or the ones that still exist in the present, the better off we are. We know intuitively conditions are getting better, but putting a fine point on exactly how much better is harder. And for folks that do want to know, there's the Flower Gardens Sanctuary has some of the best Atlantic side corals. It's a little known secret, but they're hard to get to. They're 50 miles off the coast. So people are always excited, like, oh my God, you got really healthy corals on this side of the world. And things are not so bad in the Pacific. There's still some great coral reef sources on the Pacific side.
Well, thank you so much. And thank you for answering all these questions. I'm sorry we don't have time to answer any more. Do you have any final remarks that you would like to say about conservation?
Hugely important, and it's not the environment versus the economy, it's the two together, and there's lots of work to be done, but again, we're very hopeful that the types of science that we're funding and the management actions that we're pursuing are going to pay off.
Well, thanks again, Jennifer, for your tireless dedication to conserving coral reefs globally. Thanks so much.